In lesson 2.3, we're going to work with slope-intercept form of a line. And you can see right here in number 1 that they ask us to find the slope and the y-intercept of the line. And so we need to keep in mind what the skeleton of slope-intercept form looks like. Y equals mx plus b. And once we have our equation in this form, which we do here, we can go ahead and identify our slope and our y-intercept. So m is always the slope. All right, so whatever coefficient lines up with m, that would be the coefficient on the x term, is our slope. In this case, it's 7. And then our y-intercept is the b. So whatever our constant is, remember that constant does not have a variable attached to it. That is our y-intercept. So in this equation, slope is 7, y-intercept is 8. In number 2, we can see that we have y solved for. We have our x term. There's no constant. There's no constant recorded here. So when there's no constant recorded, we assume it to be 0. You don't need to write it in, but you do need to understand that that makes the slope, well, actually the slope is the coefficient on x, so that's negative 13 here. That's your m. Your y-intercept, or your b value, is 0. So that means when you go to plot your first point, when we are graphing an equation like this, you're going to start at the origin. You would start at 0, y of 0. And number 3, it is not in y equals mx plus b form. So we're going to need to put it into that form. We need to get the y on one side by itself. So in order to do that, I'm going to take away 2x on the left side, put it on the right, and I'm going to do the same thing with that negative 2. All right, I'll end up with y over here and negative 2x plus 2 here. So that's our form solved for y equals mx plus b. And then I'm going to identify my slope, or my m value, as negative 2, and my y-intercept is positive 2. Now down on number 7, they ask you to find the x and y intercepts of the line with the given equation. So these are going to be where the linear graph crosses the x-axis and where it crosses the y-axis. So in this graph over here on the side, this is not a graph of any of these equations that you see here. I'm just giving you just a visual. This is just a something to look at so we can kind of explain this a little bit better. If we want to find the y-intercept over here, so they asked us to find x and y. We're going to go ahead and start with y. That would be the point where the graph crosses the y-axis, the y-intercept. When it crosses the y-axis, you can see that our x value is going to be 0. There's no horizontal movement left or right at this point right here. We just went straight up. Okay, so that means that our x value is going to be 0. So in order to find what our y is over here, then I would just plug in x of 0. And when I do that, I'll get a y-intercept of negative 1. Now, that makes sense because we've got this in particular equation in y equals mx plus b form. So we could have just looked there and said, that's our y-intercept. But this is another way to do it, especially if it's not in y equals mx plus b form. And we'll do one like that here in a minute. So that's our x-intercept, or I'm sorry, our y-intercept. If we wanted to find our x-intercept, we would do the same thing, only now we would plug 0 in for y. So I'm going to rewrite this, putting 0 in for y, and solve for my x. Okay, and so there's my x coordinate. It would cross the x-axis at 1/4. So this this graph over here, again, it does not go along with number 7. So hopefully this isn't confusing. But over here on this side is the x-intercept is down here where there's no vertical movement. So when you have your x-intercept, your y value is 0. When you have your y-intercept, your x value is 0. So I went ahead and drew in a representation of number 7 just to make sure that you see the correlation. So number 7, we found out the y-intercept was -1 and the x-intercept was 1/4. So right here, this is the y-intercept. The y-coordinate is -1. And when the y-coordinate is -1, the x is 0. So this is your y-intercept, where it crosses the y-axis. This is your x-intercept. And there is where we calculated that x would be 1/4 when y is 0. And so this is our x-intercept. Moving on to number 9, we can see already that it's in y equals mx plus b form. We can calculate then our slope as that coefficient on x, which is -1/2, and our y-intercept as +2. And then on number 13, actually, let's go back up to number 9 and go ahead and calculate the x and y intercepts. So we're going to do the same thing. We're going to find our y-intercept by setting x equal to 0 and calculating, and you can see we come out with our b value. So that makes sense. Our y-intercept, if we're going to write that in coordinate form, then we will write that as 0, 2. All right, so when x is 0, y is 2. That's where it's going to cross the y-axis. And then set y equal to 0 to calculate for your x. And you would end up with, I'm going to have to come over here, and you would end up with an x of 4. So if we're going to put that in coordinate pair form, when x is 4, y is 0. Now going down to number 13, it is not in y equals mx plus b form. That's okay. You can put it in y equals mx plus b form, and then you'll quickly be able to see the y-intercept, the b value. Or you can just do it straight from here. And I can say, well, if x is 0, then y is going to be -3. Writing that in coordinate pair form, when y is -3, x is 0. And then I can do the same thing, only reverse. Put 0 in for y. And x is 3 when y is 0. And in coordinate pair form, it would look like that. So you could plot both of those points and join them together with a ruler and get the graph of this line right here. It's just another way to graph these. So now we're going to actually graph them. We're going to start with our y-intercept. So that's our b value. I'm going to plot that at 3, at y of 3, because that's my y-intercept. Then I'm going to look at my slope. I see my slope is a +3. That's a whole number, so I'm going to put it over 1. Now, on this graph, unfortunately, there's no room to go up 3 and to the right 1. That's what this tells us. Remember, this is vertical movement. This is horizontal. Positive means up in the numerator, positive means to the right in the denominator. Because we can't go up and over, there's no room. They didn't make the graph big enough. We can make both of them negative, because then -3 divided by -1 is still +3. We've just changed it. We've renamed it, so now we have room to go down and to the left 1. So I'm going to go down to the origin and to the left 1. That gives me 2 points I could connect, or I could do it again and get a third point. Go down and to the left 1, and then you would connect those dots. All right, on number 20, we can see that we do have it solved for y. Our b is this -6 here. We have to notice that we have the graph numbered in 2s. So we can just go down 3 spots for -6. And now our slope is -2. It's a whole number, so I'm going to put it over 1. That negative sign in the numerator means vertical movement down, and the positive in the denominator means to the right 1. So I'm going to go from this point down 2, which is just 2 spots. I'm sorry, just 1 spot, and to the left, to the right 1. Okay, I could do the same thing again. I can go down one and to the right one. I'm going down one because one space down represents 2 units in this particular equation. Now number 21 is not in slope-intercept form yet. Y is not solved for, so we've got to do that first. I'm not going to go through all those steps, as I trust you can do that at this point. But when we solve, we end up with 1/2 x plus 1. So now we see our y-intercept is 1, a positive 1. And my slope now is 1/2. So my slope is 1/2. That's indicating 1 unit up and 2 units over. We don't put it over 1. It's already a fraction. We don't need to make it a fraction. We only have to do that when it's a whole number, not already a fraction. So I can do that. And I could also, just to show you, like what we did in number 19, instead of having it positive 1 over positive 2, I can rename it as negative 1 over negative 2, because that's the same thing. Those will cancel down to 1/2. And then I can start from this point here, my y-intercept, and go down 1 and to the right 2 and get another point and connect those dots. All right, now in 31, we're going to put this into application with a word problem. The caterer for your class picnic charges $1 for each hot dog and $2 for each hamburger. You have $48 to spend. They want you to write a model, which means write a function, write an equation that shows the different numbers of hot dogs and hamburgers that you could purchase. So you've got a total of $48 to spend. That's your limiting factor. And we can see that we've got $1 for each hot dog. We're gonna call hot dogs, the number of hot dogs, X. We're gonna give it the value of X, the variable X. And then it's $2 every time you buy a hamburger, and I'm gonna call those Y. And so we need to come up with an expression for the number of hot dogs and how much it's gonna cost. If we're calling them X, then every time we buy a hot dog, we're going to have to multiply it by 1. That's our expression for hot dogs. We're going to add to that our expression for hamburgers. So every time we buy a hamburger, it's going to cost us $2. We have $48 to spend. We're going to assume in this case that we're spending all of it. So we're going to put an equal sign there, $48. Okay, I'm just going to simplify that down to look a little simpler, a little easier to solve, and there's our function. You could stick any number of hot dogs in and then calculate. If I bought 10 hot dogs, calculate Y to see how much money is left to buy hamburgers then. Right, and number 32, we have a similar type problem. Don't let the percentage signs confuse you. We're just going to turn those into decimals. We're going to turn that 2% into 0.2, 0.02, and then our 6% into 0.06. Remember, percent means out of 100. Okay, that's out of 100 or per 100. So if I have 2%, that means I have 2 out of 100. And if I turn that into a decimal, that's how I got that 0.02. Okay. We know that every time this car salesman sells a used car, he's going to make 2% commission. So I'm going to call used cars X. Every time he sells a new car, he makes 0.066% in commission. So I'm going to call those Y. And he wants to earn $7,000 commission this month. Write a model. All right, just means a function, an equation that shows the different sales amounts of used and new cars that can be sold to reach his target. So if we have the expression of every time he sells a used car, he makes 2% commission. Add to that, every time he sells a new car, a Y, he gets 6% commission, and he wants that in the end of the month to total $7,000. All right, so if he sold 10 used cars, we'd stick 10 in for X, and we would calculate out Y, and that would tell him how many new cars he then had to sell to make his commission goal.